because it didn't look like Tcl' at all. So I thought I would explain how it actually translates in this Tcl' as a starting point. So this slide, let me see if I can projector do that a little bit. Really is big. Okay. So at the top of the slide here, if I can get the mouse to move over there. There we go. So up here, if you look at a typical statement that you might process in Tcl', you can break it up into a series of words. I think everybody understands that. What happens when the TSL engine is running is at first it decides if it's in strict Tcl mode, in which case it's going to process everything exactly like Tcl. If TSL mode is enabled, it then goes in and adds some additional rules for what it does with the words. So as it's processing, the first thing it does is it finds the first word. Then it sees the question marks mean optionally. It looks for a second word. At that point it stops. It doesn't care what's in the rest of the statement. And we have 3 examples of what's going to happen that don't look like Tcl to show you. One, which was the question Carl asked me last night, was about the equal sign. The second was showing how to do this call and what the parens actually do. So the first part I'm going to also make clear here is what these letters and codes mean. W is just words. R means from this key up here, rest of the statement, whatever follows. And T means this object when you see it in a moment, and C will stand for command objects. This is what's known as the Lex level 0 in the parser. All right, so what I'm going to do is pull down the shade there a little bit. So we'll reveal the next part. And then I'm going to pop it back up. So what happens in level 1 is the first question it asks is there a word? Is there a second word? If there is a second word, does that second word have some kind of a symbol in it, and only symbols in it? In our case, in this example, it does. It has an equals. In each of these other ones, it does not. So when it sees that, the first thing it says is, oh, I'm going to flip the arguments. The actual command is the symbol itself. And equals is just an alias for set. So it sees the equals, and it flips the 2 arguments and rewrites it as being that expression. So it's now equals x12. That's all that's happening in that phase. But that means that these are what in Smalltalk would be called a binary selector. But in any of these scenarios, it's just flipping the arguments around to decide where the command is located. So in this next step, it then goes and says, okay, I figured that out. In the next line, it's basically saying, does W have a dot? Okay, let's do my dot with this slide. I'm just going to put this one. It's looking here and says, does W have a dot in it? W0, the first one. Our example here with x dot cosine does. So while that's a single word, this whole piece is one word, it's going to split the word up because it's got a dot in it. It's going to decide that the left-hand side of the dot is a T object. It's a this. It's a receiver, or a me, or a my, or whatever you want to think of it as. And the right-hand side of the dot is the command. And so it's going to rewrite that. And it's going to say, there's the command, and the T object is now the first argument. So these 2 cases are mutually exclusive. So if it's a symbol, it's never going to be a dot form. If it's a dot form, it's never going to be a symbol. After it's done that phase, the next thing it does is it comes down here and asks the question, what's that command? It doesn't want to proceed. At that point, it's identified the command. It knows exactly what the command is. It's now going to go find it. Before it finishes anything else, it's going to bind this command. Once it binds the command, it then asks the command whether it wants to defer additional tokenization and substitution phases. So by doing that, it allows for commands to actually not have any of their arguments, their words, etc., expanded or substituted. It's under the control of the command. That makes It allows you to write more natural-looking if statements, for loops, and a variety of other expressions. So that's the next step it does, is say what defer mode does that command want, and if I can't find the command, there's nothing to even further execute. So at that point, it's bound the command up, and it knows what it should do with the rest of the arguments. What it does with the rest of the arguments depends on what the structure of the remaining stuff is. If it's pure Tcl, then it's just going to process it as Tcl. But if it's got TSL extensions in it, then it will look and see, did the arguments begin with a set of parens? If they did, then I'm going to take the parens, and they're going to be broken up into semicolon delimited groups. And the first semicolon delimited group will be broken up by comma delimited elements. And that maps down into exactly this set of words. So that's the first word right here, getting mapped down into simply expression of that. The second one is mapped down into expression of this. And any remaining semicolon arguments are passed as literals in through to the receiver. After that, everything else is processed as straight Tcl, whatever happens outside the parens. That's the only magic that's going on. And when you define a proc, you can say whether you want any of this substitution and expansion to be deferred or not. There's nothing else, and this simple set of additional transitions enables writing a very clean grammar in terms of wanting to have something that looks exactly and behaves exactly like JavaScript. You can write all of JavaScript with that same transformation. And you can do a bunch of other things as well. And it has the added value over top of JavaScript that you can have additional arguments, which you may or may not have seen when I did some of those queries, after the parens, which don't exist in JavaScript, where all the arguments are Tcl arguments. And that turns out to be very useful and convenient.
How do you pass an equals to as the first argument, literal equals, as the first argument to a command?
Oh, if you want to pass as literal equals, all you have to do is put curly braces or anything else around it, right? So then you've escaped it. That's trivial.
So, and you have some slight additional syntax restrictions, except if you're in pure TCL mode, then it would just pay. You don't have to quote the equal.
You don't have to do anything. That's right. Basically, none of these are only activated if you're in TSL mode. Otherwise, they're not activated. It's just processing Tcl. And all it's doing, literally, is this set of transformations, and then it's Tcl underneath.
It looks like you've reworked the XPR to do an assignment.
So, yeah, well, actually, depends on how you think of it. So what this is, yes, I've reworked the XPR to do an assignment and a few other things. It has it has a richer syntax. You can call functions, you can new up objects.
Either that, or if he applies the setting transform to the XPR language, that you can do an assignment in XPR right now.
Yeah, you should be able
Open
to.
square bracket set
That's true. Okay.
to 0, close square
Which is
bracket.
effectively what actually happens. That is under the covers what is exactly going on in the XPR.
Okay, so you're doing that. You're going to parse that I equals 0 just as you would a command.
Yeah.
Okay.
Yeah. And there are a few other commands that get to go through in TSL mode the same way. But in fact, under the hood, it's all running Tcl. It's just doing these transformations on top.
The key innovation you've got at work here is that you're interleaving your parsing with consulting of the command, which is going to eventually have control.
Yeah.
How this differs from fundamental Tcl is Tcl makes the parsing pass completely through before it asks what command it is going to be.
Right. And I want to comment on that because we were talking about the whole JIT or the whole demo that was being done last night at the end of the day, the one everybody was just talking about. So one of the things that I spent a lot of my language career specializing in is being able to write jitters and high performance things. And I wanted to make sure I had a mechanism for being able to completely JIT Tcl and do it so it could be extremely fast. And this extra phase in here of deferring and making those decisions actually enables building a super efficient JIT. I could get into a deeper discussion of why, but it actually allows taking this language and almost completely compiling it into native code with a fairly simple transform. This is very fast compilation. And parsing, I mean, the thing that got me so excited when I first looked at Tcl in this space and trying to address the issue was I could do everything that JavaScript had. I could define more parts of the language than JavaScript has that are baked in JavaScript. And I could parse this up at amazing speeds. The actual Tcl''s simple rules for parsing with these extra transformations parses code at blazing speed. I have essentially a couple hundred line completely standalone piece of C code that parses all this and builds me a full AST ready to go. And that's really, really compact. So that was really why I was excited in part about what Tcl' as a language allowed, was just a few extra transforms like this, and I could make it do all the other things and be very fast parsing, because the rules are very rigid. They're actually very regular. So that was the first thing. Yeah, hyper-regular, which makes it great for parsing. I mean, it's really nice. So the second thing we were talking about a little bit was this whole notion of what happens with the caret. We've been discussing that a bit. And so I thought I would share a little bit of two things that happen under the hood. So the actual underlying object model is based on my AOS engine, but for all intents and purposes in this discussion, it's a JavaScript object model. So every object can have a variable number of named values added to it. They can also have index values added to it. You can call those slots if you like. In implementation practice, it may not actually be done that way, but it will appear to be as a user. Object sizes within my engine have an overhead of 1 pointer size. So there's basically either 4 bytes or 8 bytes in the header, and there's no other data to describe the object other than the actual slots that hold the values. The second part is that as a namespace system, whenever you create an object that is of type proc, and function methods are just special cases of proc, I'll explain that in a moment. But as you create a proc, it takes on a name, and it can be, in the cases of func and method, inside of another namespace or a module, and it automatically picks up the name from the outer module as its full path name. And those get minted. So there's this notion of minting, which in JavaScript, for example, you get all these anonymous functions, and they never get a name, and you can't figure out where they live. But in fact, they're all the time getting assigned to one place, and they never change. Minting is the idea, and you do this with namespaces is another object we're not talking about here, but minting is the idea that when that type of object gets assigned to something, the thing it's assigned to can mint it, because the thing itself has a name, so it knows how to name both parts. And so you get, what this allows you to do is talk about paths to objects dynamically. So these become dynamically named objects that then bind those objects that have a unique name. If it then gets assigned somewhere else, but it's already been minted, its name doesn't change. So it has a canonical name. So minting is all about getting a canonical or a unique name based on where it's first minted. You can also unmint and allow it to remint, but that's more of a special case. This allows you to get a lot of the power that happens in static languages where you declare flattened namespaces, but at the same time not be stuck with these ideas that I can't remove these things around or put them in later, or just assign them to get them named. So it frees up all the initialization models. So what a func and a method do is this. Proc lives in a particular namespace by default. And it lives in a namespace that happens to be called :super. But that's mostly to protect it from getting polluted. That's invisible to any normal use. It just happens to not live in the globals. So the second part is funcs. When you declare a func, it's exactly like a proc with one difference. Its location will be within whatever context it was declared in. So if I'm inside of a script, and that script happens to be a module, and I simply declare a func, or if I'm inside of a proc itself, then that func's name will be minted as a path from its outer containing minted space. And methods, the only difference for methods is that methods, and we'd have to go look at what an object model looks like, methods happen to be attached by default, if you're declaring them inside of a func, to the prototype object, so that if you make new instances of that func or that proc, which you can new up objects, then it will automatically inherit all the methods that have been declared on that class. This is a JavaScript model, right? So you have a type, you can make instances of that type, and all the instances of that type have the behavior that's assigned to that type's prototype object.
So why have a separate func type that has this characteristic instead of just providing that information, making that information available to all routines via something like the subcommand of input, for example.
Let me explore. So explain the question.
So you have here proc and you have func, and the difference, the way you just described func, is that the context is the current call, so it's dynamic.
Right.
So instead of having that be an explicit, separate type of object in the system, as it is now, why not just provide the command info current context?
Okay, so I got you. It isn't actually a different command. If you actually look at the implementation, proc, func, and method, they're the same function. It's the same trick with aliasing that is done, for example, with executable. They're exactly the same function, but the name determines the anchor for where it gets minted.
Is that information also available through some info command?
Yeah, I don't know. Yes, the short answer is that whenever you're inside of any function, you can ask for its context, you can ask for the function, you can ask for its mint name, you can get all of that stuff. Ask for its container. And in fact, I use that very heavily. So oftentimes I'll write things that look up the parent tree, the mint tree, and then go look at near neighbors to find things because it allows the code to be completely modular. And what happens is this avoids any function name collisions. Right? But it also gives you a very clean syntax when you're declaring a class because you really only have to say func and whatever the definition is, nothing else. You don't have to go qualify where it lives or anything because it's by implication, which is following the 80-20 rule. 80% of the time when you're using it, that's exactly what you wanted to have happen. I can show you exactly here. Let's see if I left that out. So here will be, for example, like a socket listener class. And here it's got its body function in it. And here I've declared some things in a prototype. And here I've just declared a bunch of methods on that. So let me start off with what the definition is. There's the proc. I said it takes a variable number of arguments. Dot, dot, dot is just an alias for a way of declaring args. Ampersand colon says that what's going to follow is JSON format. And then I've simply said I want this object, this type, to inherit from a type socket. And then I basically said, here's the body of the function. And then I've said I want to actually create a prototype object and set these values on it. And then I've added these methods. And then, go ahead.
I'm sorry to interrupt, but I'm just sitting here wondering, would it be fair to characterize this language as Smalltalk that can wrap itself in JavaScript's clothing?
No, there's really not. It's really not. So fundamentally, it's not Smalltalk. Smalltalk is class-based, not prototype-based. Smalltalk has a very different syntax. And Smalltalk also has a very other characteristic, which I think I mentioned in a much earlier talk, that things like arrays and indices are all one-based. And that requires a different library design. So, no, it's not. This is very Smalltalk, or very JavaScript-like, right? But all that's happened to make it JavaScript is that syntactic sugar you saw me talking about earlier. I could rewrite everything that's here using pure Tcl' format. It's just a transformation. So the other pattern that you'll see in some of this, I mean, you can see that, in fact, when I do default arguments, it's really just escaping exactly in Tcl'. There's other things. Ampersand is a reference to a variable rather than the variable itself, and question mark is a shorthand for saying, I want a reference to this variable. This dot closed is the same as this. That's really the same thing. And ampersand is saying, I want a reference, and question mark is saying, does it even exist? So this is a shorthand for a way of saying, is this variable defined or not? If it's not defined, if it's defined, go ahead and exit. If it's not, keep going. Question mark in front of a variable says it's optional. It means if you don't provide it, that variable will not be defined in the function. Rather than having a default value, it won't actually even be defined. So you can provide it, but it won't be defined. And just looking quickly through some other simple examples that are sitting in here. Yeah. So that's almost all the basics of that syntactic sugar. The other piece I wanted to share was some of what happens with the $sign. So one of the things that I added in was the ability to do inside strings or other places. You can do $bang, which is the same thing. So if you do $bang square brackets inside of a string, it's the same thing as doing regular square brackets. But in TSL mode, it turns off square brackets escaping. $$ is a double D reference because everything can be an object. And every object has a string representation, which is to turn into a JSON format. So if you if you're inside of a string and you had this sort of, if I was in a quoted string and I had some name and that thing happened to be an object, $ says, don't just give me a reference to it, actually turn that into JSON and put that out as a string value. $: is actually just an option. It's optional to provide the colon, but if you're embedding inside of HTML, CSS, or other places, it happens to allow you to directly reference variables and expand them. So you can basically take a piece of HTML, a piece of CSS, or anything else and say, expand all the Tcl' arguments in there. And what it does is it will only look for a pattern where the name starts with $: If it sees that anywhere, it'll substitute any variable it can find whose name begins with that directly into that source. And that's really borrowing directly from Richard's stuff and how TH1 did expansions, but trying to make sure that it stays very clean and not being ambiguous with any other languages like JavaScript having $signs all over the place inside of HTML, CSS pre-processed tools. So the other thing, which I think we talked about a little bit, is if you have ampersand a variable and then assign to something else, that just automatically upvars that variable for you. So if I go ampersand A equals B, it will then make B share the exact same variable as A. And I can reference, and A could be, or sorry, and B rather could be anywhere. So if I have something like whatever B happens to be, however that resolves as an expression, this will then be alias to that. So they'll actually share the same slot. So this is like, it's equivalent of symlinking. And then finally, the other thing is anywhere where it encounters a paren, a command, who happens to just be parens, it assumes you meant to say expression. So you don't have to actually say expression. You can just put parens anywhere, and it's automatically like saying expression. There is one Smalltalk piece for being able to cascade. We won't talk about that. The other thing is that because it has an inheritance model, if I'm referencing, if I have an object and I want to access A, : B, : C, B might not be directly a slot on A. B might live in some inherited prototype object. If I want to actually access it so it's specifically only on that object, I can say bang. And that means I want to find B, but only if B is directly on A, not if it's inherited somehow. Those are the only other significant rules in there. Ampersands, like I said, are just references to object. They're a deferred substitution. So it says, I'm talking about this object, I can pass it around, but I don't want you to actually do any substitution with it. And that's what we call that's what I call a variable reference. Anything on the stack, any object can be stringified and represented that way. You can talk about the stack, we'll skip over that. There's a set of basic namespaces that the system defines. It defines system, it defines shell, it defines app, global's defined, it defines script, and it manages these for you to tell you everything about your process, your environment, the state of things that are going on. There's a set of naming patterns which do come from the Smalltalk heritage. But the core system doesn't know any of that. That all happens in the kernel boot piece, which you can replace. That's all done in the Tcl piece at the very bootstrapping part when it runs, and you can replace all of what gets constructed here because it's all constructed after Tcl starts running in the interpreter. The other thing is that it's very common, you'll see in my variables, hyphens in the names. So you can have camel case or hyphenated names. ats are allowed in part of a name, but they have a special meaning. Any variable that happens to be called this dash is generally considered to be reserved, so that I reserve almost no names. I think there's only 3 words that are reserved for the language. Everything else you can do what you want with it. And then there's a bunch of typical pattern usages, which is if it's a function and it happens to fall in a category, it generally starts with the category, like file dash operation or whatnot, as to how it gets grouped for procs. And these are the typical key variables. And this is talking about the include system, which we don't really have time to go into. But I wanted to give a basic survey because I didn't really do that on the first day. And I want people to understand that underneath it's a Tcl' engine. It's just doing these transformations. So that is both the end of my talk and the end of the slides. So thank you very much, everybody. Do I have any questions? Go ahead. Does anybody have any questions they want to ask? Or?
Do you have a lot of outside code that uses this notation? A lot. I mean, do you have to interact with large libraries that this thought process is the driver for?
So this can also process JavaScript.
I see.
So you can blend completely JavaScript and Tcl'. So you can go both ways. It's really a hybrid that allows you to do both JavaScript and Tcl'. And the core engine performance is equal to and better than Node.js in most cases.
Okay, and to deploy your Internet of Things, being able to do both languages in one framework, I can definitely see the benefits from that.
I would tell you that, so some of it's just me, to be very clear as the motivation, but there are a number of issues with trying to use JavaScript and the JavaScript engines that exist, right? And there's a number of advantages to what Tcl' has to offer, and blending them both gives me the best. I can use libraries from either world, and I can package the whole thing in a single binary that I can deploy on pretty much any architecture I want. There's a whole path. There's another discussion about the engine itself and how it's designed, but it has very little OS dependency. So it can live pretty much anywhere. And the second part is all the content, assets, and packages can live in a single SQLite database as a version file system. So deployment becomes trivial.
Yeah, I'm seeing that, if basically if everybody in the room had to come in with the same set of constraints, we probably would, that's the logic is.
The goal is to allow it to be possible to have a binary in the BusyBox model where you have web servers, you have all the core things you need to build on device and server scenarios, all in one unit. So SSL, certs, everything you need. The second part of the goal was to have it be packaged in a way that was easily and trivially deployable in very constrained environments, which is really what this talk today, this afternoon, this morning was supposed to be about, right? But I shared most of that talk in other slides. But IoT environments, devices are very constrained. Server environments are often very constrained. Cloud environments are very constrained because you pay more money the more things you put in. If you can deploy a single binary that looks like an app and does a bunch of stuff, that's a lot cheaper in cloud assets that you have to require to do it.
And rewriting entire libraries of JavaScript just isn't in the cards.
Well, as a practical matter, if you want to be, so one of the things that I didn't share too much, but at the very beginning of my first talk, what I think is very important is that for a language to matter, it has to be relevant. To be relevant, it has to be approachable by the mainstream audiences who feel that they have very low friction to consume it, to understand it, and equally high value they get out of it from existing skills and knowledge or code bases that are out there. Right? So the reason for blending Tcl' and JavaScript was really based on all of those considerations. And the goal is to allow you to do Tcl' and JavaScript together seamlessly and get all the perf benefits that you get out of a JavaScript engine for running things like Tcl' and doing other stuff.
You might have said it earlier in the series, but did you have? Is there a place we can download this add-on or whatever for Tcl' and run it and experiment with it?
Yeah, so that's a really great question. So the short answer is I'm happy to share it with people individually. I don't want it to get into the wild for one reason. I'm sure if it happens, I'll end up with this legacy problem. People will use it, they'll want to ship with it, it always happens, and I don't feel yet it's fully baked.
Okay.
So I'm happy to make it available to anybody to play with under the, under some set of constraints where they don't try to put it into the wild and they don't try to release stuff with it. That's really my only requirement for it.
What about long-term?
So long term, and that was sort of my rule of 9, it's going to be free, it'll be readily available. What I won't do is I probably will not release the source except to paying customers who want to license the source. There'll be no restrictions on using it. I just won't release the source to the whole thing. And there'll be additional libraries that I may build and add on that I won't necessarily release. But I'm actually going to ensure there's an ecosystem for other people to build libraries that completely compete with anything I may be doing. Because my goal in this is not to make this the product. This is the tool to make products.
So this is the language I've always wanted to use. I can tell you that already. I listened to it last year, and this year I feel more that way. But I also am convinced that I must use all the language that I have access to the source code.
So the short, well, you'll have access to all the libraries, the source libraries, but the actual engine itself, I won't do that. And the reason I won't do that is because I don't know how it will play out in the first couple of years. All languages and things of this nature have a lifetime, and there's sort of a timing of when you release what pieces. I would expect fully, then say 5 years after it's out, there's little reason not to release the source code to the engine. But I wouldn't expect to release that in the first couple of years.
I think the reason is several of us have been in businesses where there was some proprietary thing like this that we built the business on, and the company went out of business and didn't
Totally
source it, or you get hit by a beer truck.
Oh yeah, no, I totally get that. So that will all be taken care of. So I will make sure if something happens to me, the software will get released, etc. I understand how extremely important it is for someone to take a dependency to be able to have that thing survive in perpetuity, be maintainable. And I will absolutely be taking care of that. One minute. That's not the reason why I don't want to release the source. It's got more to do with what happens if I release some of this source when I'm trying to actually edge out some of the things that are happening with Node.js and other engines, and I know what they'll do the moment they get the source. So it's more my deferring that activity happening. I have no other real intention. I just don't want to give a bunch of stuff away before it's got a certain amount of momentum. Because I know I know that community well. I know a number of the core developers who build those things, and I know how they react, and they all know what I built.
So one example of this historically is black box, component Pascal black box.
I think so. One of the things that's interesting, if you look at some of the target audiences for things like IoT and otherwise, they literally don't care, because I know that any corporate customer building with us will happily pay me for a source license, which I will happily provide them. But if I just release the source, I also equally know what's got. If there's no quote skin in the game when I give them the source, they'll do whatever they want. And it doesn't matter whether I have a copy left, copy right, copy upside down license. It won't matter. And that's really the key factor. It's about timing. Otherwise, I would happily do it again. Personally, it's frustrating because I would love to totally release all the engine source and have people play with it. But it's not what I think at this stage anyway is the right path. It would be different perhaps if I had a $20 million plus company sponsor, right? I originally had wanted to do something like this under Microsoft releases, right, where I wouldn't have cared. And I would have forced Microsoft to open source. So I hope that helps sort of answer the question.
That all makes a lot of sense.
Yeah. Thank you for indulging with the extra time.
I think, sure. No, but it is time to close up and move on. So